So we're good to go? Alrighty. So we're on parent functions and we're looking at square roots, and your parent function is going to be the one y equals the square root of x. And I'm going to kind of give you a picture of here. And I could plug in a 0, right? Mm-hmm. And I'd get 0 here. If I plugged in 1, I'd get like 1 here. If I plugged in 4, I'd get like 2. So it is going to go out like this. I know that's not a perfect one, but that's a general idea of what your square root function looks like. You should see a picture of it on there. Mm-hmm. If you were looking at it, it kind of looks like a parabola, your parent function of a parabola that's been turned on its side, mm-hmm, with just that one side. Okay? This is a function because if I drew a vertical line through it, it would hit it at most one point. So if you're looking at this and you want to say, okay, what is my domain? What numbers can I plug in? What's that going to be? Can I plug in any number? What's the first number I can plug in?
X is greater than 0.
Okay, so it's going to be...
Or equal to.
Okay, X is greater than or equal to 0. X is an element of the reals. This is, it's an element of the reals, but it's not all real numbers, so this is the qualifier. X is greater than or equal to 0. Okay? Excuse me. Range. We said domain, so let's do range. Now, when you're doing range, remember you want to look up and down. What can the number be?
Y is greater than 0 or equal to 0.
Or equal to 0. Y is greater than or equal to 0. Y is an element of the reals. Basically, that just means that it's any number bigger than 0 that is a real number. It's not just integers. It's not just rationals. It's any number. Okay? Y-intercept. Where does this baby cross the y-axis?
At the origin.
At the origin, what do we call that?
0, 0.
0, 0. Okay, and how about the x-intercept?
Same thing.
Same thing. Okay. Symmetry?
None.
So you're just going to write a big fat none. And asymptotes, this one has none.
Okay.
Okay. I'm going to erase this here, and we're going to talk about intervals of increase and decrease. You have that big line like this, right? Mm-hmm. Go ahead and make a place for where 0 is. And nothing is happening on this side, but what's happening from 0 onward?
They're both heading toward infinity.
Okay, so it's increasing at that point. So, where it says intervals of increase, do you see that down there? We're going to make it the interval of 0 to infinity. This does not mean the point 0, infinity. This means on the x-axis, the graph is increasing all the way from 0 up through infinity. Okay? Intervals of decrease would be none. Relative local max or relative local maximum would be none. This baby's never going to have a maximum. Is there a minimum?
Yes.
What's the minimum?
0, 0.
0, 0 would be your minimum. Okay? All right. So far, so good. I'm going to erase this now. And we're going to talk about intervals of concavity real quick. Again, we've got our little deal here. And 0 is pretty much where the action is. There's nothing happening over here, so I don't have any concavity over here. What's happening over here? What kind of concavity do we have? It is concave down. Okay. Intervals of concave upward is none. Intervals of concave downward would be from 0 to negative infinity.
Wait, 0 to positive infinity?
What did I put?
Negative infinity.
Okay, sorry. 0 to infinity. Points of inflection. An inflection point is where it changes concavity. There are no points of inflection here.
That'd be like a S or something.
Yes.
It'd be like
yes, like a polynomial type thing,
yeah.
You know? You get something in here where it changes from being up to down. We don't have that here. It's nothing to up, but that's not a change in concavity. Okay? That's just different. End behavior. As x approaches negative infinity, what does y approach?
Well, there is no...
Okay, not applicable.
Okay.
As x approaches infinity, what's y doing?
Infinity.
Infinity as well. Okay, awesome. It asks for an alternative or an alternate form of the equation, and so we're just basically going to give you our general equation that you build up from the pairing equation. It looks like y equals a square root x minus h, and on the outside plus k. Again, you know, your H is going to affect your left-right shift. Your K is going to affect your vertical shift. Your A is going to affect, you know, how steeply this grows or how wide it is. Okay? Alrighty, so that's going to do it except for up where it says locator points right under the graph. There's 2 locator points. One would be 0, 0.
And the other's
And
H comma K.
That's correct. And the other one is H comma K. Okay? This is for the parent function. This is for your general function. Good to go? Alrighty.